it's Miss Childs here, and today I'm going to do a very quick little video about symmetry lines. I noticed that some of you are finding this really easy and others are a little bit confused, but I noticed in particular almost everyone was confused about a couple of shapes. So let's have a look and see if we can find out some symmetry lines. So I have a regular square here, and to find a symmetry line, all I want is for both sides, when I halve it, to be identical. So there's one, they're identical on both sides. There's two, identical on both sides. And then I've done a vertical and I've done a horizontal. Let's see if I can do some diagonals. So I'm going to try and bring the corners to each side. Is that identical on both sides? Looks good to me. And what about the other one? Perfect. But that's the last one we're going to get out of that. So how many did we get? We got the vertical one, the horizontal one, and the two diagonals. So that's 1, 2, 3, 4. Perfect. Now you'll notice that this shape has 4 sides. So it's a perfect square. Okay? So it has 4 perfectly equal sides and 4 equal corners, angles. And that means it has 4 lines of symmetry. 1, 2, 3, 4. So we're going to make a rule that every time there is a perfectly equal or regular shape, then it will have the same number of lines of symmetry as there are sides. Now, there's something that doesn't really match that rule, and that is a circle. Circles are a bit weird because you think, oh, I can fold that in half. Nice. I can fold it in half the other way. Perfect. But you can also fold it in half around the entire shape, leaving no gaps between each of your different lines. So do you see how I'm getting loads of folds all the way around? Because I can fold a circle in many different ways, so it has lots of lines of symmetry. This is a regular pentagon, okay? And that means all its sides and all its angles are the same. So what was our rule? It should have the same number of lines of symmetry as it does sides. So a pentagon has 5 sides. Let's test that out. So we've got the vertical, 1. We can turn it slightly, 2. We can turn it slightly again, 3. We can turn it slightly again, 4. And our last little bit that's not matching, there we go, 5. And that's all of the sides lined up. So you see how it's exactly the same every time I turn it. And it can be easier when you're looking at a shape. When I look at a shape like this, part of my brain is telling me I can't do all of those. But as you turn it and you look at it again with fresh eyes, with each turn, you will be able to see that line down the middle that you keep creating, where you can draw, okay? Or where you can fold with whatever you're using. Alright, so just turn the shape and see if it helps you see what you need. If you're working on an exam paper, you can move the exam paper around to see it from different angles. Okay, so did it match our rule? We got 5 lines of symmetry and we have 5 sides. Yes, it did match our rule. Okay, so if you are ever struggling but you can tell that you have a shape that has equal sides and equal corners, making it a regular shape, you can use this rule, okay? Let's look at a shape that is not a regular shape. So here we have a rectangle, which is not a regular shape, because even though it does have matching parallel sides, it does not have all the sides the same length. This length is not the same as this length, okay? So we can see, I'm going to do a vertical first and see if that matches. Yeah. Then I'm going to do a horizontal. Does that match? Yep. And what about a diagonal? No, the two sides do not match, so I cannot do a diagonal. So I have 1 and 2 symmetry lines. Let's take a look at this shape now. So I'll just let you see it for a minute. It's not a triangle because we have that extra flat side here. Okay. Do you think that this has any lines of symmetry? Well, my gut reaction when I look at this is, well, I can't see how to make one, but I can check. So I'll do a vertical first. No, that's not the same on both sides. I'll do a horizontal. Well, that's not the same on both sides. Are there any verticals that I can do? Diagonals even? Nope, that's not the same. What about in the other direction? It almost looks the same, but it's not. We've got this little bit here that doesn't match up, and this corner up here doesn't completely match. So that means there are no lines of symmetry on this shape, okay? So when you get given a strange shape, just try out vertical, horizontal, diagonal, diagonal, and see if anything appears. So let's take a look at some triangles then. I've got 3 triangles here. Okay, so the first triangle I have here is an equilateral triangle. All sides are the same and all corners are the same. So what's our rule? I think you've got it. Let's try it out. Can I do a vertical? And if I've cut this right, which hopefully I have, we will get the right amount. Okay, there's our vertical. Looks good to me. Okay, so that's 1. We do a horizontal. Absolutely not. That looks like a boat. Okay, what diagonals can we do? Well, there's one. It's the same on both sides. So I've got that, and I've got that. Let's try and do the other diagonal. And that is also the same on both sides. So how many do we have? 1, 2, 3, which matches the same amount as the outside lines. I have 2 different triangles here. I have a scalene triangle, or a right angled triangle, and I have an isosceles triangle. Let's try the isosceles triangle first. Well, I think I can halve it, definitely. Let's try that. Yep, that looks good to me. But I can't see anything else that works. If I try and do this, it doesn't match. And if I try any sort of diagonal, it does not work. So I have 1 line of symmetry in my isosceles triangle. Now I have my scalene triangle. And I'll just show that to the camera. Okay, so can you see any? The only one I think could be there is maybe here. Let's try that out. So I'm going to fold it, keeping this my point. It was close, but they don't match. Do you see how the points cross over? And in different types of scaling triangle, this is probably even more obvious. Which means I don't have that one. We know from our other triangles we can't do that. And there's no diagonals that match either. So my scalene triangle has no lines of symmetry. What do you do if you see a shape you've not seen before, or you're not sure if it matches these rules? I really recommend just drawing it out, or getting a piece of paper and cutting out the shape and experimenting with it like I have here. If you're in an exam situation where you can't do that, use your ruler as a mirror and draw lines across, then compare them. Do they look the same on both sides? If they don't, it's not a line of symmetry. Try a new one. If that doesn't work, it's also not a line of symmetry. If you can't find your line of symmetry, rub them all out, and that's a shape that does not have one. But you may find that a shape that you initially looked at and thought didn't have a line of symmetry, like I know a lot of children have been getting with this one, when you actually try it, you might find some. Okay? So I hope that makes sense. I hope you've enjoyed the video. If you have any questions, let me know. Bye bye, stay safe, bye!